and welcome to this TELIT webinar, 5G IoT and the Enterprise, the current state of 5G and IoT applications. I'm Amanda Flink, Head of Global Events here at TELIT, and I will be moderating today's event. Before we start, we'd like to understand what best describes your interest in 5G. So please take a second to fill out our poll question, which you'll see on your screen now. To explain this topic, I'm pleased to be joined by Marco Contento, VP of 5G Technologies here at TELIT. Today, Marco will review how the 5G standard has evolved around different use cases, where and when MNOs worldwide have rolled out their 5G networks, and what the evolution of use cases over time will look like as infrastructure evolves. Just before I hand it over to Marco to start the presentation, I have a few quick reminders. I would like to encourage our audience to interact by posting questions. We will have time to answer some of those at the end of the presentation. Simply submit a question by posting in the box to the right of the slides. Also, please be sure to check out the resources section in the upper right-hand corner of your screen for additional information. Finally, we will send out a replay link to all attendees at the conclusion of this webinar. And with that, Marco, I will hand it to you.
But first of all, I will introduce the topic, saying that we are essentially at the tipping point where we see we are living a transition between the legacy technology such as 4G and also before 3G, and we are entering into a new era that is or is going to be dominated by 5G. We are also moving from a different, model where essentially technology was focused on satisfying personal needs for communication and also to control essentially IoT devices in the field to retrieve data. However, 5G has arrived with new promises to fulfill new use cases that were not possible before with the legacy technologies, in particular in the domain of the industry. Of course, all this has arrived with a significant effort from different stakeholders. So a lot of activities is done in the field of standardization, in research and development, also from chipset providers and providers of core technology and components, OEM device manufacturer, content application developers, and so on, to mention a few of them. Of course, all this effort will essentially enable the digital society. So, and 5G will enable, as said, also new additional use cases. IHS in this field predicted, this was actually a prediction before the outbreak, of course, that potentially will stimulate the total global sales in total about $13 billion across a broad spectrum of industry and use cases. Needless to say that all this will come with a significant effort. We mentioned before the implication and the stakeholders that have been involved in this study and development. And all this, of course, will bring a benefit to the industry in particular. And the industry will have the possibility to use this technology also in use cases that so far have been dominated by the current wired technologies. All these, of course, will require or will introduce new challenges. In particular, I refer to the requirement in terms of real-time communications that will be somehow accommodated or will be fulfilled by the new version of the standard. I refer to the 3GPP Release 16 standard. Also, introducing cellular technology in an industrial environment will require also new skill set and business model, because in some cases the service will change or the mindset also will change, because we will move from a kind of OPEX approach with essentially the service will be paid as user, not anymore will not be anymore a CapEx investment to include it or to integrate into the industry new equipments. Let's have a quick overview on the numbers that we can see from the market analysts. In terms of 5G IoT revenues, the forecast is essentially also in this case the pre-COVID forecast that will be, of course, will need to be adjusted. The projections say that we're moving from about 600 million of revenue in 2020. We'll move to 6.3 billion in 2025 with a KGR that is in the range of 55%. In terms of course, this revenue include everything. If you look at that specifically to cellular modules, and in particular 5G modules, the projection in this case we refer to FBI research was something in the range of 3 million. They predict 3 million units in 2022, and this number is going to increase with a rate of 180%, reaching 66 million in 2025. Of course, today the technology that is available, the 5G technology that is available, is essentially accommodating the needs of the current, let's say, use cases that are referring to the broadband use cases. But along our road, of course, there will be additional features that will be included in the 5G specs that will enable additional use cases, in particular for the manufacturing industry. Along with that, there is a lot of, or there are a lot of initiatives around to allocate a new spectrum, in particular for private network deployments. I can mention Germany is quite ahead of all the others. Also US with allocation of bands spectrum in CBRS that, I remind you, is a shared spectrum. Germany in particular, they have reserved a piece of spectrum in the 3.7 gigahertz for the industries. They can acquire, and therefore pieces or slices of the spectrum for private deployment in their plants. So as I said, today we have available the first wave of the technology, and I refer to Release 15 compliant devices. Anyhow, those devices are good to accommodate the need of broadband connectivity, somehow more or less the same value proposition of the legacy 4G technology. Anyhow, the player and the industry in general are keen to test these products also in their use cases in order to start playing and to get more confidence to use 5G in the industry. Of course, in view to move to the next generation that will be Release 16 compliant and will accommodate or will supply or will support the capabilities in terms of low latency communication, ultra reliable communication, and things like that that are part of the Release 16 spec. Another important aspect to mention here is that in the case of private networks, the deployments in general, or in the majority of the cases, will be standalone, meaning that both the RAN network access and also the core network will be standalone, so pure 5G. And on this regard, and we'll see later in my presentation, there will be, or there is the option to use the concept of, which is a new paradigm, the network slicing, meaning that I can serve different use cases with different quality of services depending on the needs. So, what is the third vision in this new picture, let me say? But first of all, we want to be first in the market, and we have developed a set of new products, and we have already certified this new product on several major carriers, particularly in Japan, in South Korea, and also in US on Verizon Wireless. And there are other major certifications that are ongoing. I think we plan to complete in Q1 and Q2 this year. We have partnered with a major chip supplier, and in particular, it's a leader in the industry, in particular for 5G, which is Qualcomm, and we have adopted one of the chips, in particular, second generation STX55 chipset, where we started to develop our product portfolio. We have, of course, specified the product keeping in mind the needs of our customers, in particular in the industrial space. We, of course, looking not only to fulfill the needs of broadband use cases, but also looking ahead, in particular, to fulfill the needs of private networks deployment in particular. That is a new segment, let me say, that before was somehow approached with the legacy technology only marginally, and 5G will enable particular use cases in the industrial automation, edge intelligence, supply chain optimization, maintenance, and device lifecycle management. Said that, I would say that we also take in consideration the fact that our customer want to see a smooth transition from 4G to 5G, in particular when they want to somehow upgrade their end devices that they've already developed with the legacy technology. So we have taken into consideration the fact that they expect to see the same software and hardware interfaces across the different product variants. In terms of what is our expertise in under the vision of 5G, we are an industry with more than 20 years of expertise in hardware development, in particular with RF, which is a key element in the picture when we look at the 5G, in particular when we look at developing a product supporting millimeter wave. That of course brings additional challenges, and we'll see later couple of slides on that topic. We also offer connectivity for IoT deployments, relying on global MNO partner network, and offering a unified, secure, cost-optimized touchpoint, and that is 5G upgradable. We build and design and support solution in-house, making us a true single-source IoT provider with 30 years of experience. Remind you that in the past we acquired a company that was at that time specialized in IoT connectivity. We offer IoT management for devices and connectivity and global IoT SIM cards and data plans. We offer also rich collection of IoT connectivity management tools and resources designed to get your IoT deployment to market quickly and also efficiently. We offer package plans for connectivity and one edge, and it's the first solution that reduces the time and complexity associated with adding IoT to device and services for consumer and enterprise application. We also plan to include one edge in our 5G devices in order to be consistent with the remaining portfolio of products. We are also among the most awarded IoT provider in the industry for the communication model, but also for the one edge and device-wise. One edge in particular is a module embedded software suite with prepackaged deployment and management tools that are secure and easy to use. One edge offers edge intelligence, embedded security, and connectivity service and management, enterprise integration, and centralized device management. Device-wise is an industrial IoT platform install that allow you to get your device and apps to talk to one another. You can connect your enterprise and IoT application, including those Amazon, SAP, and IBM Watson, without creating customer code. Also, we have, let's say, managed to offer to the customer the possibility to move from let's say, buying, let's say, a piece of hardware and also value-added services completely separated into as a service model, with a particular to provide specific transformation in terms of let's say, approach to the total cost of ownership of the solution. Few words regarding the evolution of the standard. As I said before, we have developed a product that is based on the first 5G standard, which is a 3GPP release 15, that accommodate the need of broadband connectivity. So we can reach with this standard the several gigabit throughput, in particular in the link. So it's more or less the evolution of the 4G value proposition, let me say, for the LTI category products. There are two additional and let's say relevant milestones that are release 16 and release 17. The first one that is more relevant for us in these days, which is Release 16 that introduce important capabilities, and I refer to low latency and I refer to ultra reliable communication. These two major capabilities will be relevant to accommodate the need of the industry, and in particular the possibility to introduce a wireless technology for the first time in an industrial environment to let's say accommodate the need of either replacing or also to support the wired connectivity in specific situations. The third milestone will be instead release 17 that will accommodate the need of a massive NTC, so machine time communication. We are all aware that today this segment is served by LTE-M and narrowband IoT technology and will evolve in the future, including the support of 5G. But as of today, we are still with the LTE-M and narrowband that, by the way, are satisfying the requirement of 5G for the time being. Other additional important aspect of Release 16 in particular that is the focus for somehow today's presentation is the support of LAN, the wired line. I refer to Ethernet, so industrial Ethernet. Release 16 will also introduce improvement on the V2X communication, which is quite relevant for, in particular, the support of NR side link, which is a new paradigm that will enable the end devices to communicate each other without relying on the core network. Release 16 will also introduce the integrated access and backhaul, and therefore they will essentially it will provide the possibility to reuse the millimeter wave spectrum, in particular for the backhaul, because millimeter wave deployment is quite critical in terms of availability of fiber, in particular, to connect the access point, the millimeter wave access point to the backhaul, and therefore there is the option in this case to reuse the millimeter wave spectrum for that purpose too. Location and positioning services, this is quite relevant not only for consumer applications, but also for industrial use cases where essentially there is a need to locate or position the asset in a plant, for instance, relying on a unique technology, so still 5G. And Release 16 also introduced improvement on the network slicing that we mentioned before. And in particular, when we come to limitations that were present in Release 15, in particular in between the interworking between the EPC, the Asset Packet Core Network in 4G, and the 5G core network, when a device moved from the EPC to the 5G core network. And also in terms of specific authentication and authorization procedures. So this will essentially benefit the deployments relying on Release 16. Of course, the industry is keen to see Release 16 devices, but as of today, I mean, the preliminary Release 16 chipsets are starting to be available, so we'll still need to wait almost a year or so to see the first devices certified in the market. What are the news that 5G has brought to the community, the digital society? First of all, spectrum. In general, the industry is very hungry of spectrum. So what has been done in terms of spectrum has been to introduce additional bands in sub-6 spectrum. But even more important, new and completely different band has been introduced, in particular referred to millimeter wave bands, so frequencies that are above 24 gigahertz. And in Release 15, they have specified 4 bands in total. Of course, you can imagine that with such a high frequency, the spectrum available is very wide. So you can easily combine 800 or even more megahertz of total bandwidth, and therefore the benefit are essentially the throughput that you can achieve and also the capacity in terms of number of users connected to a single base station. Of course, all this does not come for free. I mean, there are also technical challenges because the limitation of coverage in terms of RF coverage because the high RF path losses that we can see later. And the other aspect of 5G are surely the increased capacity, as said, with additional spectrum that has been introduced, in particular in millimeter wave, not only there, also in sub-6 bands. I remind you that in that case, on one side, we're also talking about prefarming of LTE bands into 5G. And in terms of spectrum, we do not introduce, we don't add more spectrum. But there are additional bands, in particular in the C-band, so around 3.5 gigahertz spectrum, where there is additional spectrum available to host or to support more throughput and also more customers. More devices. So with all this spectrum, of course, we can imagine that we can, or the network operator can plan a kind of layered coverage, providing service to the end user in a different way. So starting from, let's say, the more crowded areas, so shopping malls, shopping centers, and also, let's say, small venues that they can provide the millimeter wave coverage, providing more bandwidth and more capacity, up to the other areas, rural area, for instance, where they can provide 5G services using the low bands or mid bands, depending on the situations. High throughput we have just mentioned because we have, of course, more bandwidth available. Lower latency, higher reliability. So URLC, this is a typical, actually this is a peculiar feature that we mentioned before with the coming release 16, that by the way was specified in June last year, so 2020. We mentioned also new use cases thanks to the new capabilities of the standard again. So now let's have a look at the current situation. So we mentioned release 15, and let's see what's going on. So as mentioned before, there is a huge interest to try the current technology available. So 5G release 15 in particular, with the trial proof of concept in the industry. They try to see what are the capabilities they can achieve. Of course, they can only address no real-time use cases because release 15 currently is not capable to do that. The benefit of using 5G in the case of private networks, of course, is to have a guaranteed connectivity and also mobility, because if you use Wi-Fi, you don't benefit the same mobilities that you can have with the cellular, and also privacy, because you can benefit let's say, the capability of a cellular technology into your own environment. All the deployment that has been done so far, with very few exceptions, has been done in sub-6, in particular on C-bands. And they want also to start playing with the service-based architecture. We mentioned before the slicing and the possibility to allocate virtual slices based on the same hardware to differentiate and to provide a different quality of service to the different use cases and the end devices. Of course, all this will enable a wide range of use cases. Typically, the industry is now considering few use cases because they want to start playing with the technology and then to see what they can achieve, and of course, think to the next wave of use cases. Potential convergence to 5G, if I look at the today use cases, and in particular the technology they use, I've noticed that there are several technologies that are used simultaneously. I would mention, for instance, Wi-Fi combining with a wideband in order to position a product in a plant. And the dream or the wish is to use 5G as a unique technology to provide different services and to satisfy different needs. With the coming release 16, of course, we are addressing the mission critical and precise positioning, both indoor and outdoor. We mentioned private deployment, so still Release 16 is relevant for private deployment. Security is another aspect that is somehow considered since the day one of the activity in terms of standardization as 5G. Millimeter wave could be also considered as a complement to mid-bands in factory deployment to enable system capacity and gain more bandwidth and lower latency. Let's say that as of today, millimeter wave potentially can be used, for instance, if you want to use a high definition camera and you want to uplink on a MAC multi-edge computing the video, for instance, you want to do the processing. In that case, millimeter wave could be relevant if you want to reduce the time of upload. We have also to consider that millimeter wave can be easy to, let's say, keep under control in terms of coverage because the high path losses that you can have with the millimeter wave so can easily be confined inside the buildings. Release 17 will represent the next wave, in particular to fulfill the need to connect a million of devices, as we said before, the evolution of the Unity LTM and narrowband IoT. Use cases, of course, 5G will play a pivotal role in several use cases that we can imagine. Starting from healthcare, manufacturing, we mentioned energy, utilities, automotive, public safety, media, entertainment, and so on. And of course, all these use cases will be fulfilled in different phases because, as we have just mentioned, there are different features that will be released or are already released actually with the 3GPP standard that are coming or has been recently released, and therefore all these segments will not be satisfied since day one, but will need to wait the evolution of the standard, and not only that, but in particular the availability of the end devices for the system integrator that will have the possibility to integrate in their final applications. In terms of availability of 5G service around the world, I give you some, update. So if I look in particular to 5G and in particular sub-6 deployment worldwide, this is the situation as February 2021. There are essentially 140 networks that have deployed or actually commercially launched 5G in 60 countries in total. And in total, there are more than 400 carriers that have invested in 130 countries that have invested in 5G technology. And these numbers, we do not count the private deployment. This is a different situation. I do not count also the allocation of spectrum in the CBRS spectrum that has been is something that has been done in US. Among all these numbers, there are 65 operators that have been identified that are investing in standalone deployments. And if I look instead to the millimeter wave situation, in particular this situation is on November 2020, actually there are in total about 24 operators that have deployed millimeter wave in 15 countries. If I look instead at who is investing, we can count more than 130 operators in 43 countries that have invested in 5G millimeter wave, in particular on the three, let's say, more popular bands, so 257, 58, and 61. And there are 32 operators in 6 countries that have invested money in one band, 260. This is the common band in the US, in the United States. And in total, in terms of license, there are more than 100 operators that have gained the license for the 5G spectrum. Now, if you look at the situation in a different, let's say, countries, also in particular different operators, US, Verizon and AT&T are the two carriers that launched by first time in the millimeter wave coverage already in either Q4 2018, particularly AT&T, or the beginning of 2019 with Verizon. They have also deployed 5G in sub-6 bands. T-Mobile and Sprint that have recently merged together. They are offering different tier of services. So millimeter wave will be offered in dense urban areas, and the mid-band spectrum, in particular the band 41 in 2.5 gigahertz, will be used for metro coverage, in particular to provide capacity and also throughput to the users. And then they can leverage the 600 megahertz band, which is band 71, where they essentially cover the nation with 5G service. Europe instead is much more focused on sub-6 bands, even if the auction are either being recently closed for the allocation of millimeter wave or are going to be this year. But in a sense, the majority of the carriers have deployed 5G in Europe, starting from sub-6 band, either refarming the spectrum in legacy LTE bands, using also DSS, so dynamic spectrum sharing. We'll see later exactly what it is. So here we just depicted the major carriers of Vodafone, Deutsche Telekom, Orange, and Telefonica in the major countries, so Spain, UK, Germany, Italy, Romania, and so on. So we have reached already a good level of coverage in 5G, of course, starting from the cities, which are the most populated areas. Each carrier have different ambition in terms of population coverage by the end of this year or let's say next year, 2022. All the deployment have been currently in a non-standalone mode, meaning that the carrier have leveraged the 4G core network, combining the 5G radio resources in order to provide more throughput to the end user. Next is a look to Asia-Pacific, which is composed, at least we're looking at the major carrier, of course, here. China, which is quite peculiar because it's the first country where they have deployed standalone mode along with the non-standalone, in particular for China Mobile. All the other have deployed standalone. They are focused on sub-6 bands for the time being. The speed of deployment is quite fast, probably the fastest in the world. Now, looking at Korea, South Korea in particular, and in Japan, both countries have deployed both sub-6 and millimeter wave bands. All the carriers have started to develop 5G. In Japan in particular, they launched 5G last year, and they are now looking at the standalone deployment. Standalone in Japan is particularly important also for industrial applications, for private networks. Korea is also very much focused on 5G, and in particular with the use of 5G in IoT space, so for industrial market, and they started to launch the standalone mode at the end of 2020. Telstra is focused currently on sub-6 development of deployments, and the auction for millimeter wave is going to be this quarter, and they will start rolling out millimeter wave probably late this year. All right, a few words regarding China. For a standalone deployment, they are essentially forced the mobile handset supplier to provide standalone support since beginning of last year. They are also adding a new band, which is in the 700 mega spectrum, band N28. Let's go to the next. We'll have a quick overview on the capabilities of 5G. Hope we have still time to show something. So we mentioned before the use of millimeter wave. This is, of course, a piece of spectrum where there is a possibility to supply much more throughput and also capacity to the system to support more customers, but also lower latency compared to the high bands because they need different sub-carrier spacing that is using this piece of spectrum. However, of course, this comes with a lot of challenges. In order to, say, somehow deal with the high path losses that are typical of this spectrum, the technology makes use of beamforming, beam tracking in order to focus the RF beam more efficiently against the antenna, the access point, essentially. In terms of deployment, of course, this is also a challenge because being the fact that the coverage of millimeter wave is quite limited in terms of coverage and or from the network operator perspective, of course, they have to provide or to install the base station with a certain level of density, and therefore they need also to provide or to connect those base stations also with fibers and other technology, like also millimeter wave as well. Coverage, of course, is a little bit problematic because it can be spottier. To provide, a constant coverage is quite challenging. However, there are pros and cons on this because that is an aspect that it can help in the case of private deployment, in particular in an industry environment. We mentioned before dynamic spectrum sharing. Well, this is quite, popular, a feature that is adopted by the network operator for the reason that we all know that currently there is a certain level of 4G coverage worldwide, essentially provided through the current bands that we all know. However, because they essentially need to deploy also 5G and not always new bands are available, but they want to reuse the bands that have been allocated on 4G. This feature can help because they can essentially allocate the spectrum, the current spectrum that is currently allocated for 4G, also for 5G. And this is done dynamically. So in this way, they can serve either the legacy users or devices, also the new devices that are 5G capable. This is essentially a software feature that can be deployed, by means of software update without a specific need or without the needs of doing hardware update of the network. Aside of that, of course, there are new bands in sub-6 spectrum that are combined or offer also to provide more throughput and more capacity. The other important aspect is the service-based architecture we mentioned before. This is a brand new paradigm essentially in the mobile industry, where 5G is essentially seen as a software as a service oriented architecture, and that is the foundation of the network license we mentioned before. The services here, the network function element here essentially interact each other with a mechanism that is based on a registration, discovery, and authorization mechanism, and will essentially provide the foundation for the service-based architecture. This is in particular relevant when we see, for instance, use cases in the field of autonomous driving or industry automation, where we look at a private network, for instance, or massive IoT. In that case, for instance, you don't need low latency because you can survive also if you have 15 or 100 milliseconds of latency if you are not in a hurry to get, for instance, a temperature value, and so on. The next important milestone of 5G is security. 5G is secure by design. 5G has been built on a software and service-based architecture, being the fact that everything is virtualized here. So we talk about software-defined networking, network function virtualization. So these are all fundamental elements of 5G, and all these, of course, come with a new security concern. So because they are open, flexible, and programmable element of the implementation, of course, new, path of security threats are possible, and therefore have to be taken into consideration. Other aspect of 5G that is more looking forward, let me say, is an alliance, a new radio light that is, work item of the release 17 GDP activity. This part essentially will accommodate the need to find a replacement technology based on 5G standard for the current, or let's say, legacy 4G LTE, and in particular refer to mid categories devices in the range of Cat 1, Cat 4. So in a sense, devices that will not need the same throughput of iCat or let's say premium tier 5G devices, and on the other side will not need low latency capability, like we mentioned before in the case of Release 16 for automation, industrial automation, and so on. Where we are in terms of let's say stage, we have ongoing almost 200 proof of concept around the world with several customers with different use cases. We will see later some relevant use cases for that. We have certified the first industrial modem in Korea with a major network operator, and we have also the first commercial 5G router in Japan. There are, however, several others that are close to launch their product in the field, and in particular based on our 5G solution. A few reference of use cases that we envision, in particular that are fulfilled by the first wave of 5G, in particular supporting broadband connectivity. So first relevant segment for sure is the enterprise routers and gateways, where essentially the customer needs are to fulfill the demand of quality of services, to provide the business connectivity, bandwidth, and better user experience, and also solve bottleneck connectivity, so they can either be let's say hybrid system combining fiber with wireless, or simply be only wireless, depending on the case. So you can imagine that there is a huge customer base in this case that are asking for this kind of capability. IoT gateways that are let's say similar to the previous, but more oriented to industrial application. Not only that, but also to support the first responders. For this, in that case, they require also fallback and manage in access or FirstNet certification in case of the US. Video streaming, this is also an important use case where essentially we refer to uplink-centric application, and therefore the uplink capability of the device is quite important to fulfill. Private 5G network we mentioned before. We mentioned the initiatives around the world, in particular in the location of private spectrum, or and the implementation of 5G, in particular to fulfill the needs of the industrial automation and also other use cases. Smart grid is also an interesting segment that is, let's say, looking at 5G, and in particular the use of 5G for reducing the latency and provide connectivity where essentially there is no landline communication, either fiber or DSL or other. Last is mobile compute is quite a classic use case where we refer to downlink-centric use cases. Essentially the device are more focused to downlink email or web browsing and things like that, and there is the need to provide worldwide coverage. The product that we offer, FNI 80 and FNI 80 millimeter wave, support millimeter wave, that are essentially, they feature essentially the same capability with the exception of millimeter wave that is supported by the M version, the FNI 80M. And the last is the FNI 82 that is focused on mobile computing only, and it can fit a standard M.2 form factor, so 30 by 42 millimeters. Okay, I finished with my presentation, so we can move ahead with the question.
Thanks, Marco. Really, really great information here. Before we get to the questions, I am going to drop one last poll for our audience. If you'd like to have one of our experts contact you directly, please respond here on the poll that you see on your screen, and someone will reach out. We've now got time for a few questions. I've got a couple great ones here, and we'll do our best to cover it in the time we have left. Marco, first question I've got for you here. How does 5G overcome all the hype that we hear about?
Well, we all know that 5G technology has introduced a lot of promises like fast speeds, reduced latency, and also improve the capacity of the system. But of course, all these capabilities will not come overnight. As we see today, I mean, the 5G technology that has been deployed and is being deployed by the carrier essentially are an extension of the current value proposition of 4G technology, essentially increasing the throughput capabilities. Of course, 5G, as is today, is not yet prepared to support all the necessary promises that we have mentioned. In particular, I refer to the industry transformation and with the introduction of low latency. So it doesn't mean that 5G will not bring all the benefit that it has promised. So it's not only a dream, but it's a transformation that is coming. It will take its time in order to be used by, let's say, all the stakeholders, industry in general.
Great, thanks. Next question I've got. Can you talk to me a little about frequency spectrum for 5G networks?
Sure. Among all the let's say news that 5G has introduced, there is the topic of the spectrum. In particular, in order to provide more throughput and more capacity, the industry has introduced the additional spectrum to the, let's say, to the possibility for the devices to connect. In particular, I refer to frequency bands that has been introduced in the millimeter wave spectrum, so from 24 gigahertz up to 50 gigahertz essentially. So in this additional spectrum, that is quite high and then introduce a lot of challenges, in particular for the propagation, radio propagation. Of course, there is much more bandwidth available, and therefore the device can leverage more throughput, and also we can also support more devices. The challenge here, of course, is the coverage that you can achieve with the millimeter wave spectrum that is quite limited, and therefore is suitable for covering a small area like shopping mall, stadium, and things like that. On the other side, we still see use the bands or spectrum that has been used so far for the legacy technology like 3G and 4G in particular. So in that case, we talk about refarming of the previous spectrum. And in addition to that, there is also a lot of interest in allocating frequency bands in what is known as a C-band, so around 3.5 gigahertz, where the technology makes use of paired spectrum, so actually unpaired spectrum, so TDD bands essentially. So when you have a receiver and transmitter on the same bands. In that case, also in the C-band, there is a lot of bandwidth available, and therefore also in that case, you can have, let's say, a good compromising coverage and also capacity and also throughput, I would say. So this is essentially the key elements of the frequency spectrum that has been allocated for 5G.
Great, thank you. Here's an interesting question. What impact has COVID effectively had on 5G rollout and the development of new standards?
Well, first of all, looking at the standard, remember we started with the lockdown last year when we were in the middle of closing the 3GPP release 16 activities. So essentially the release 16 stage 3 has been shifted by 3 months, so it was closed on June 2020, along with the SN1 freezer that was also planned in June 2020. So now release 16 is out, and of course the work is continuing on the release 17, 3GPP, that has been delayed to June 2020. And this is at least the target date for the completion. And this is based on the assumption that the face-to-face meeting will resume in the second half of this year. Because since March, April last year, all the face-to-face meeting has been essentially transformed into online meetings. And this, you can imagine, delays all the activities of the standardization. So due to this restriction and lockdowns, there will be potential delays in deployments, in the deployment of release 16 when we look at the carriers, and that are now focused on deploying stabilized release 15 and are now planning to deploy release 16. Of course, you can imagine that all the infection that has been around due to COVID-19 and the fact that people have started to work remotely and there is a limited access to the labs, all these have caused a slowdown of the deployment, but also on the device side, we have noticed also the slowdown of all the certification activities from the test houses, but also from the carriers. These are essentially the impact that the pandemic has generated till last year, essentially.
Yeah, it'll be interesting to see what happens over, the next few months too, as we continue to figure all this out. Next question we've got here: how are relations between China and the U.S. affecting 5G rollout and the evolution?
Well, this is, sure an important question. Everything started before the outbreak with a trade war, in particular related to the Chinese giant offering the 5G infrastructure, and I refer to Huawei in particular, which is one of the key players offering 5G infrastructure. The fact that the US has somehow prevented Huawei to sell the core element to the carrier, essentially in US, has created an impact not only on the business of Huawei on the US market, but also has influenced also other countries like New Zealand, for instance, Australia, and so on, that has taken a similar decision to avoid to use Huawei for their 5G deployment for security reasons we all know. Of course, doing that means that all the carriers, or at least the carrier or countries where there is this kind of limitation, the carriers now had to essentially restart the RFQ process and redefine the list or the potential supplier for the 5G infrastructure. And this, of course, will generate or is generating delays in the deployment of a 5G network.
Yeah, thanks. Last question I've got here. Can you explain what is the difference between low power and high power millimeter wave device operation, and when should we use one or the other?
Well, the low power millimeter wave antennas are suitable essentially for small devices, and I will list the handset in general, so tablet, smartphones and things like that, where there is the need to have really small antennas to place inside the devices. And also there are limitations in the emitted power. So we refer here to power class 3 devices that has a minimum peak ERP that is can be either 22 or 20 dBm depending on the bands. These are small devices, of course, has a limited power consumption that usually are installed in the device that can be mobile computer or mobile handset. Only one device is active. This is because those are installed in a different direction, and therefore only one usually is active. In the contrary, when we refer to high power millimeter wave antennas, we refer to antennas for specific devices like CPEs, in particular outdoor CPEs, so customer premises equipment. So those are boxes that are installed outside the buildings and usually are fixed installation, and where all the antennas are essentially looking in one direction only, looking at the base station essentially. So in that case, because the antenna is fixed, the spherical covers can be relatively narrow, and therefore an higher minimum ERP can be adopted by the device in order to achieve an higher throughput performance that compared to the mobile device instead. So these are referred as a power class 1 in a 3GPP specification, and they can allow essentially a minimum peak ERP that is in the range of 40 dBm or 38 dBm depending on the bands considered. These are essentially the two types of use and different power level that are specified by the GPP. There are also other classes they have defined that will come, and they will come in release 17 3GPP spec.
Great, thank you. I believe that's all the time we've got for today. Marco, I really appreciate your time and the great presentation information. Audience, please be sure to check your inboxes in the coming days for the replay link. Thanks so much for joining us and have a great day.
Thank you, Amanda.